Just want to make a short video to address something happened recently that is both amusing and sort of sad in a way, and surprising in a way. So a while ago, someone sent me an email about a post that was made on Knife Dogs and asked me if the information being presented there was correct. Now, normally when somebody asks me a question like that, if the answer is yes, that I feel that what's said represents what we know, then I'd sort of say yes. But if I disagree, I would go to wherever that person said the thing, comment about it there, and then direct the person an email to my response. And the reason I do this is because I believe that if you're going to criticize somebody, they should have the right to read your criticism, be aware of it, and respond to it. You shouldn't criticize somebody behind their back where they can't see it and can't respond to it and can't correct you if you're mistaken. Can't defend their original assertion. So I've been active on Knife Dogs very weekly, like less than a post per week for a short period of time. Recently, Ed Caffrey was cited in a discussion thread about 5160, and a segment of what Ed said isn't exactly traditional if you look at Metallurgy text about heat treating. And you won't find it in any data sheet if you pick it up how to harden 5160. What Ed does, and a number of other ABS guys do, and they argue it is beneficial for grain refinement, is that after they quench the blade in the oil, they leave it in the oil overnight, and sometimes people advocate leaving it even longer. And they argue again this refines the grain of the steel. ME2 asked the question, well, how could that happen? What could be causing it? What could leaving it in the oil overnight be doing to it? Ed never responded to it, and I came back in and said, well, essentially what you're doing is a very long temper at a very low temperature, and there are a number of things which happen in tempering at low temperatures, and they're based upon the diffusion of carbon. So for example, one thing is transition carbides form, and another thing is even at really low temperatures, and that happens between 0 and 100 degrees Celsius, carbon forms other particular substructures. Darrin, who's a moderator there and knife maker, came in and warned me to stop posting false information and said tempering doesn't happen at those temperatures I was talking about. Now again, this is an odd thing to say because I'm talking about what's being presented in material science peer-reviewed journals. These aren't just sort of whimsical things people make up. I mean, you're talking about research from people who've studied the steel, looked at it with scanning electron microscopes, X-ray diffraction, studied the exact substructures that happens in the steel and speak about it in a very particular manner. And this research I was talking about had been done 30 and 40 years ago. It's not exactly new. It's wrote about in foundational textbooks like the kind that Krauss writes. They're very well known. So I came back in and corrected him and I said, yeah, it does. Tempering is more than what you normally see when someone asks you what temperature should you temper A to for a knife blade. Tempering happens essentially at any temperature that you hold the steel under the critical temperature. That's what tempering means if you look it up in metallurgy textbooks. And there are particular reactions that take place at very low temperature. They'll happen at room temperature. Again, it depends on the elemental composition of the steel. But they will happen even at room temperature. So they are going to happen in the oil if left overnight. And I said, based on the fact that these particular substructures of carbon are going to form, and they could serve as nucleus points for the austenite-martensite transformation in the repeated quench, they could be what's producing the grain refinement. And I further said, I haven't read anyone study that particularly in the literature, but it is well known that more nucleation sites produces finer grains, and that precipitation of carbides will do exactly that, though it's normally done at a different temperature. Normally you'd be up around, they temper very, really high, like around 900 degrees or something like that. It's very commonly done in ultra high carbon steels to produce very tough, very plastic states, again by multiple quenching. It's well known. So I came in and corrected that, and I cited an actual materials reference. One of the guys who first discovered it, and again, this is decades ago, this is known. So I then get a warning from the moderator and a PM that basically says, this is my last warning, stop posting false information. And I come in, I basically say, again, it's not false, present what I'm talking about specifically when I say tempering, that it means the materials definition of tempering. Talk about the fact that this is peer-reviewed research I'm talking about, not opinions. But I said, you know, if you don't want to hear that and you're moderating the forum, that's fine. I won't post it, no big issue. He then comes in, again, calls it false information, lies about me, makes statements that are not true, and then locks the thread down. And I think that's both sad, because the other thing he did was he kept saying that he didn't understand what I was talking about. He doesn't know what transition carbides are. He doesn't understand any of that. He doesn't care about any of these technical details. He just knows it's wrong. And on one hand, you're sort of like, wow, how can you not understand what someone is talking about at all? Say that it's wrong, and then act in that kind of manner. And it's a very amusing thing on one hand, because you're like, it reminds me of that joke Chris Rock does about people being proud of their ignorance and championing it as if it's something that you should get exclaimed for. But the other thing, it's sad because these are people actually giving advice. Like, these are people actually instructing other people. This is a moderator on a discussion forum where people are going to learn how to make knives and discuss it, and openly ignore metallurgy. Again, gave references to exactly what I was talking about, specifically cited foundational work that's decades old. It's a sad thing. And unfortunately, it's much too common in the knife industry, where a knife maker or a manufacturer will make claims, and you'll argue something and say, well, based on the literature, that's, you know, completely false. And you'll get this, well, it doesn't matter what material science says, it doesn't matter what's in the literature, I just know it's wrong, and will give no justification for it. It's one of those weird things that you would think that knife makers and knife manufacturers would look to science to figure out how to make better knives, because everyone else does. Everyone making industrial tools, industrial knives that actually work for a living, looks at the literature, obviously, to find out what materials they should use, how they should process them. It's a huge glut of research done on exactly that process. But for some reason, people believe that once you get to handheld knives, all that science and metallurgy goes out the window, because there's something magical about a handheld knife that makes it defy the laws of physics. I don't know. It's one of those weird things where you look at someone talking about a Japanese katana slicing up rifle barrels, and you're thinking like, yeah, okay, that's a cool fantasy story. Hope you have fun with that. And that's the sort of approach that you see when people are talking about heat treating 5160. That's the kind of viewpoint that they have. It's just a weird, funny, amusing little thing, sad in its own way, that someone is so ignorant and frightened and shocked by metallurgical data that that's the approach that they would take, like Superman avoiding kryptonite. And on a positive note, not all makers and manufacturers are like that. There's plenty of makers and manufacturers who look to materials data and science as a positive thing that they can grow and benefit and learn from. So, I mean, those are the guys you work with. And the other guys, have fun with your fantasy and, you know, rifle barrel chopping. These are some serrated blades by Kyle. I'm going to put a link to his YouTube channel in the description. These are custom patterns that he's sort of invented, designs, innovated. I'm going to be looking at the performance of these, how they cut, how they enhance slicing aggression, durability issues, sharpening issues, and it'll be kind of fun to play around, but I haven't done any sort of serious work with serrated blades in a while. Also some very nice handle designs. And one of the other things that Kyle does really well is that he's always playing around with secondary retention, and what he has done here is put a hole in the handle which lines up with the hole in the sheath, and then basically he has a pin with a little detent ball on it which fits in there as a secondary lock. So when you really want high retention, you can just poke this in and then you go around using the knife, you just hollow it out. The only thing that I would add, and I'm going to put on this, is you'd want a little elastic, I would think, to, you know, connect this on the neck, 'cause you don't always want to take the chance of losing that. So that's the only thing I'm going to add on it. So it'll be interesting to play around with these and see what comes up out of it.